Hello everyone, my name is Chen Pei Xiang and my student ID is 2220196. I'm really excited to show our experiment on comparing machine learning algorithm today. Let's start with the background. Our aim is predict hotel reservation cancellations. We use three popular supervised learning algorithms: decision tree, KNN, and SVM. Hotel management has limited computing resources, so our model must be accurate and simple to give managers quick and useful predictions. Now let's move on how we set up these models and run the experiment. The first one is decision tree. For decision tree, we set the random seed as 42. Why did we do this? We did it to make sure that if others want to repeat our experiment, they will get the same result. After training the model, we did something interesting. We get the features' importance, and then we made a horizontal bar chart of the top 10 importance features. This chart helps us understand how the model makes decisions easily. Now, let's talk about KNN. We use grid search CV to find the best value for the parameters. We test the value from 1 to 11, like 1, 3, 5, 7, 9, 11, to get the most accurate result. We use five-fold cross-validation after all the tests. We pick the best model for our predictions. Next, let's talk about SVM. We decide to use a linear kernel for classification, just like decision tree. We set a random seed to make sure our result are the same every time we run the experiment. And remember, the training data for these models come from the training set we got during data preprocessing. The results of the experiment are interesting. You can see the table. First, the decision tree is the best in terms of balance. Decision, recall, and F1 scores for both classes are close. The decision, recall, and F1 scores for both classes are close. Its overall accuracy is 87.2%. It's also fast and easy to understand. When we look at the important features, we found that lead time and average price per room are the key factors for this model. Now, let's look at KNN. It has a high recall rate of 0.91 for class 1, but for class 0 is lower at 0.73. We think this might be because our data is high-dimensional. It makes the distance calculations in the KNN model not work well. This overall accuracy of KNN is 84.8%. Finally, SVM. It also has a high recall rate of 0.91 for class 1. But for class 0, the recall rate is only 0.62. This shows that SVM model often predicts class 1, even though its precision is okay. Its overall accuracy is only 81.2%. It didn't balance the performance of the two classes well. In conclusion, the first one, we can find the best model. Among the three algorithms, the decision tree is the best. It has a high accuracy and it's easy to understand, so it's perfect for predicting the hotel reservation cancellations in the real life. From the perspective of the model optimization suggestions, we can try reducing the dimension of the data or change some parameters for KNN. It might help it handle high-dimensional data better. For SVM, we can adjust the hyperparameters. These changes might improve its overall performance. Another discovery is about feature importance. We can learn that lead time and average price per room are very important. These two features are key in the decision-making process, so in real hotel business, we should pay close attention to these factors. Through this experiment, we have seen how well the decision tree works. We also have some ideas to improve KNN and SVM. In the future, we can keep working on these models to make them better. Thank you for your listening.